Alright, so today we're going to talk about Chapter 9, Section 4, Factoring to Solve Quadratic Equations. Our learning objective is to solve quadratic equations by factoring. So you guys have to take note. Let me highlight. I'm going to highlight most of this, so in green. So the zero product property is that for any real numbers a and b, if a times b equals 0, then either a is 0 or b is 0. So that's pretty important. Let's write all that down. For any real numbers a and b, if a times b is equal to 0, then a is equal to 0 or b is equal to 0. One of those guys has to equal 0. So let's look at our examples. If x plus 3 times x plus 2 is equal to 0, then x plus 3 is equal to 0, or x plus 2 is equal to 0. And then if we follow this out to its conclusion, x is either equal to negative 3 or x is equal to negative 2. These are the possible solutions. So when we look at number 1, and it says x plus 1 times x plus 5, times x minus 5 equals 0, we have two possible solutions, so we write both of them down. Either x plus 1 equals 0, or x minus 5 is equal to 0, and we have to solve both of them to find the possible solutions. So we're going to solve x equals negative 1 is a solution. And x equals 5 is a solution. Both of those are required to be correct. Let's look at this guy on B. 2x plus 3 times x minus 4 is equal to 0. That means 2x plus 3 has to equal 0, and x minus 4 has to equal 0. So I have to solve both of these equations. I'm going to subtract 3 from both sides. And then I'm going to divide both sides by 2. So x is either equal to 3/2 or x is equal to 4. All right, we're going to get a little bit more complicated. So now we're going to take the factoring we did from Chapter 8, apply it, and solve. So a little bit more sophisticated. So if you look at the first one, we have m squared minus 5m minus 14 equals 0. And I'm going to want to factor these out. So we have to ask ourselves, which two values multiply to give you negative 14 and add to give you negative 5? I'll tell you, one of them's got to be negative. So what two numbers multiply to give you 14? 7 and 2, and because this 5 is negative, the bigger number has to be the negative 1. So 7 is the negative 1, 2 is the positive 1, and negative 7 times 2 is negative 14, and negative 7 plus 2 is negative 5. All right, so to solve this, easy peasy, we just have m minus 7 equals 0, and m plus 2 equals 0. M is either equal to 7 or m is equal to -2. Just for fun, I'm going to skip B because it's a lot like A. And I'm going to print out a room because I have a big writer, ginormous handwriting. So here, I'm going to factor this guy, 2A, 1A, and then 18. So I need two values that multiply to give us 18. And I think, what do you guys think? -9. And two negative numbers. How about 6 and 3? Because when I FOIL this out, I'm not going to delete all this. So 2 times A is 2A squared. 2A times -6 is -12A. -3 times A is -3A. And -3 times -6 is +18. These two guys, -12A minus 3A is -15A. So it matches up. Just checking to make sure my factoring makes sense. So once it's factored, we can take each individual component and let it equal 0. And then we solve. +3 divided by 2. I promise all the fraction ones aren't going to be 3/2. I promise. So A is either equal to 6 or to 3/2. All right, so now I wanted to show you an example of when everything isn't set equal to 0. How do we get a scenario where it is equal to 0? And this is where we not only have our floaty, but we have a life vest as well, because we're not going to drown in the sophistication. So in this case, when you're trying to find the solution of a quadratic, and the quadratic is when it has a square on it, we want everything pushed over on one side of the equation and just a big fat goose egg 0 on the other. So in this case, I'm going to add 49 to both sides. Please remember, you cannot combine that 49 with anything over here because they don't have the same like terms. So when I add 49 to both sides, I get x squared plus 14x plus 49 equals 0. All right, so I'm going to factor this out. Two numbers that multiply to give us 49 and add to give us 14 would be 7 and 7. So I could either have an answer that is -7, or it could be -7. Let's just circle 1, since both of them are the same. All right, let me show you how this looks in word problem form. This is number 34 out of the section. You have a rectangular koi pond, and I do actually want you to draw this picture because that's one of the fun things about. So draw this picture in your notes. So it's 6 feet by 8 feet, and we have enough concrete for 72 square feet of walkway. What should the width of the walkway be? We know it's going to be uniform. And we want to think of how we can write the outer dimensions of the walkway and how we can represent the total dimension of the area of the walkway and the pond in two different ways. Okay, thankfully the area of the inside of this pond, how do we find the area of a rectangle again? Yeah, it's length times width. So is 8 times 6. So we know the pond of the area, thankfully, is 48 square feet. What we don't know is the area of this little strip right here. So my thought is, we know the area of the pond. We can probably find the area of the whole outside thing. If I subtract the two areas, so the total area minus the area of the pond should give us the area of the walkway. So I need to find a little formula that tells me the length and the width of this rectangle with the walkway on it. So I know that this guy is x, this guy is x, and this guy is 8. So my total distance here is x plus 8 plus x. The reason I chose to show you this word problem is you guys are on track for taking exit exam, for taking college entrance exams. Anytime you do in education world, you'll find a test. It seems that these little walkways where you have pieces of x, you have to know how to add them together, show up. So this is pretty typical of what you'll see. So my total length is 2x plus 8. Using that same process here, where I know that this guy is 6 plus x plus another x, or 6 plus 2x is my width. So if I want, so we wrote the outer dimensions of the walkway as 2x. How can you represent the total area of the walkway in two ways? So total area, so our total area would be two x plus 8 times 2x plus 6. And then the area of the walkway is this guy minus the area of the pond, which we found was 48. So if I were to write this down, it would be 2x plus 8, 2x plus 6, minus 48. And if we wanted to write it a second way, we can multiply this out. Okay. So 2x times 2x is 4x squared. 2x plus 6 is 12x. 8 times 2x is 16x. And 8 times 6 is 48. And then we have the minus 48 that goes on the end. So let's simplify. And we can write it the second way. 4x squared, these are like terms, 28x. So I can either write it like this, or I can write it like this.